Hello, my name is Merwa Al-Salame, and in this video I'm going to demonstrate the work for Comp381 Assignment 3. So in the first part of the code, we load the diabetes dataset from the skitlearn. Then we convert it into a pandas data frame so we can see the defaults in the target value. That's the output, and then we want to explore the data. So we check the dataset info, summary, statistics, and then we want to see the mean average of each feature. And here we use this to see the standard deviation of each feature. And then, of course, we want to check if there is any missing values in every column. And here it indicates that there's no missing values, so we're good to go. Then we use the histograms of the data for each feature. This helps us understand which feature might be more useful for prediction. And then for here we compute the correlation, and then we sort the feature with the strongest correlation to the target value in the descending order. That's the smallest and that's the biggest. So next we want to see the key mean closer. Here we created 5 groups using key mean closing on the target value with a random state of 22. That's the last 2 digits of my student number. And then we stratified sampling with 10% test set, seed of 22%. And this is just to split the data into training 90% and testing of 10% using the stratified sampling. So next we wanna split the training data into feature X and target Y, and same thing with the data testing. Here for the training testing aligner regression model, it just tries to fit a straight line through the data. So the score here, it shows the error because it's higher, means the model is not capturing complex patterns well. So now we move to the ridge regression, and the value here is still linear, but it adds regularization to prevent the model from becoming unstable. So the RMSE is similar to the linear regression, and that means both models behave very similarly. Next, we want to train and test the binomial regression model. So these models add more complex curved relationships. First, we want to test the degree 3, and the output here captures more patterns and has lower error. Now we want to test the degree 5, and if you look at the output, we see that it has even lower training error, but it's a sign of overfitting. So the model starts memorizing the training data instead of learning general patterns. Next, we want to see the nonlinear regression. And this, we first scale the data because the CVR performance best with normalized inputs, and the CVR can capture nonlinear patterns, but it's still training errors show that there's underfits compared to the other nonlinear model. Lastly, for the random forest regression, it's an assemble model. It trains many decision tree and average their results, so it gets the lowest training error, and that means it fits the data extremely well. But it's very low error can also mean slightly overfitting. For comparison, comparing the linear and the ridge regression underfit because they are too simple, and the binomial degree 5 and random forest are closer to overfitting, so the binomial degree 3 and the random forest gives the best balance. And that's it for this lab. Thank you for watching.